Now let's take a look at a very nice result. So for a function 1 plus x raised to power p, its Taylor series centered at 0 can be actually found by this formula. And because this formula involves binomial coefficient, we call it binomial series. Again, it's just technically speaking, it's just a Taylor series. It just has a fancy name. And this result is actually pretty easy to prove because so here's a really short proof here. So you can look at f of x is 1 plus x raised to power p, and you can find f prime of x is going to be p times 1 plus x raised to power p minus 1, right? And f double prime of x is going to be p times p minus 1 times x times 1 plus x raised to power p minus 2. I'm going to just do a couple terms, like just do these 3 terms. And when you evaluate at 0, so the first one will be 1. The second one will be f prime at 0 will be p, because if you plug in x equals 0, this term will be always 1. And then the next one will be f double prime will be p times p minus 1, right? Okay, now if you look at your coefficients, C0 is going to be f of 0, which is just 1. And C1 is f prime of 0, which is p. And C2 will be f double prime of x over 2 factorial, which is p times p minus 1 over 2 factorial, which is exactly p choose 2. Okay, p choose 2. So similarly, C3 will be p choose 3. I'm going to skip in the detail, but you can do the algebra and verify they are the same. And C4 is p choose 4. So therefore, if you expand this summation, it's actually when k0 you're going to have p choose 0 x raised to power 0, which is 1. And then p choose 1 when k is 1, p choose 1, and then x raised to power 1. And p choose 2 x squared, and p choose 3 x cubed, and so on and so forth. Isn't that this is just 1? And this is just p times x. And this is my c2 times x squared, which is c2 is right here. And this guy is my c3, which is the coefficient for x cubed. So actually they are the same thing. That's why this is Taylor series. You can just use the the Taylor formula, compute all the terms, and you can actually see each term the coefficient is actually the binomial coefficient. Okay, so that's a quick kind of short proof. And I have to highlight this guy right here. This is good when x absolute value of x is less than 1. If x absolute value of x is greater than 1, this doesn't converge. The series doesn't converge. So this is something that you need to pay attention to. Now let's take a look at the next problem. Consider this guy. I'm gonna rewrite that so that they look alike. Okay. So how I rewrite it? I'm gonna rewrite it into. Let me use the red color. I'm gonna rewrite it into 1 plus x raised to power 1/2. In this case, the p is 1/2 in this formula. So with that, I'm gonna expand it. So square root of 1 plus x is gonna be p choose. Let me use the summation notation, which is summation k from 0 to infinity. 1/2 choose k times x raised to power k. So when k is 0, this is 1. When k is 1, which is 1/2, choose 1 times x, plus when k is 2, 1/2 choose 2 x squared. In case 3, 1/2 choose 3 x cubed, and so on and so forth. Alright, and then do the algebra here. This is easy. 1/2 choose 1 is always 1/2. Anything choose n choose 1 is always n. Okay, the next one will be, okay, let's do this algebra. 1/2 minus times 1/2 minus 1, which is negative 1/2. Well, now we have two numbers on top. We are good now. Divided by 2 factorial, which is 2. X squared plus the next coefficient will be 1/2 times negative 1/2, and then times, so subtract 1 one more time, negative 3/2, divided by 3 factorial, and then x raised to power 3, and so on and so forth. And which is, simplify it. Next one is actually negative 1/8 x squared. The next one, if you it will be positive, and this is 6 on the bottom, and there's a 3 actually can cancel, and actually it's 1/16 x to the power 3. The next time, if you compute, it will be negative 5/128 x to the 4th. Okay, so this is it. This is how we find the power series using this binomial series. The next, let's look at how we can apply it to approximate this square root of 1.04 to 3 decimal places. Okay, which means the remainder is less than or equal to 0.001. So in other words, remainder must be less than or equal to that. Well, first of all, if you can observe, you may see that it's alternating series. This is an alternating series. Okay, because the sign alternates, plus, minus, and so on and so forth. So therefore, for alternating series, the Rn is less than or equal to Am plus 1. Okay, that's the remainder theorem. Therefore, I'm gonna look at this Rn. To look at Rn, well, first of all, to this square root of 1.04 is the same as square root of 1 plus 0.04. And because our f of x is square root of 1 plus x, basically this guy is the same as f of 0.04. Okay, now the Rn, in other words, what I'm trying to say is x is 0.04. That's what the information that we need. So if you look at, let's trial and error here, because this is alternating series. It's fairly easy to trial and error in this particular case. I'm gonna take a look at this term. Okay, so if you plug in 0.04, let's see what we get. 1/8 times 0.04 square, which is actually 0.00, how many zeros? There were 4 decimals because there are 2 decimals here. When you square it, 4 decimals divided by 8. So which is 0.0002. And you already see that this is already less than or equal to 0.001, which means this condition is already satisfied. Okay, so with that means you only need 2 terms, then you can achieve this accuracy. So therefore, I have to erase this for now, and then let me continue to write from here. So from I'm gonna say because, this means because when n is 2, the R2 of 0.04, we just computed it, right? So it will be 0.04 squared divided by divided by 8. This is coming from here. I'm sorry, less than or equal to. This is my A3. This is my term, the third term. This is equal to 0.0002, which is less than 0.001. So we just need two terms, which is P1 of x. And why P1 of x? Because when we have two terms, this power is 1. That's why we call it P1. So P1, I'm not going to call it Px, P1x. I'm going to call it P1 P1 of 0.04, because we're approximating f of 0.04. So 1 plus 1/2 of 0.04, we get 1.020. This is accurate to three decimal places. Okay, so this is for the part B, and let's take a look at the part C here. So in the part C, I really want to make sure that you don't want to do this 1 plus 25. You don't want to do that. That will be wrong, because in this case, you might think f of 25 is equal to square root of 1 plus 25, which is square root of 26. However, we cannot use this binomial series when this x is 25, because the binomial series, the x must be less than, absolute value of x must be less than 1, right? So it fails to meet this condition. Okay, therefore we cannot do that. Well, here's what we can do. You can consider this square root of 26 as 1 plus 25, square root of 1 plus 25, and then factor out the 25, right? When you factor out the 25, you get 1 over 25 plus 1, which is square root of 25. You take it out, which is 5, and inside the square roots you have 1 plus 1 over 25. Okay, and what is 1 over 25? It's 0.04. 5 times square root of 1 plus 0.04. Okay, your alternating series should be 5 times, if you scroll it up, and we actually have the results above right here. So it's right here, the result is right here, and let's use that. So it's 5 times, 5 times, we are gonna say 5 times, this is actually f of 0.04, right? 0.04 for this part. So actually it's 5 times f of 0.04. Okay, and which is 5 times, and the 0.04 will be 1 plus 1/2 of 0.04 minus 1/8 of 0.04 square, and the next term will be plus 1 over 16 0.04 cubed, and so on and so forth. Okay, and then you can distribute 5 into the series. So I'm going to distribute that into the series. Okay, and minus 5/8 0.04 square, and so on and so forth. Okay, 0.04 cubed minus. Now because this is our alternating series again, you just need to, how many terms do you add to secure the 3 decimal places accuracy? Just compute each term, and actually this, if you do the algebra, this term is actually 0.001, and therefore you just need 2 terms to get to the accuracy. So you just need these 2 terms. Okay, so square root of 26 is actually approximately equal to 5 plus this guy. This would be times 0.04, and it turns out to be about 5.1. Okay, so we are done with this example.